Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog. This episode is brought to you by Airbrake. Airbrake is full stack real-time error monitoring. Get real-time error alerts plus all the information you need to fix errors fast. And in this segment, I'm talking with Joe Godfrey, the CEO of Airbrake, about taking the guesswork out of rollbacks. Joe, imagine a developer has found a serious problem and they're trying to figure out what to do, whether to roll it back, yes or no. And if they roll it back, what do they roll back? Because they may have released 10, 20, or even 50 new commits that day, and they're just not 100% sure which commit caused the problem.
That's exactly where a tool like Airbrake comes into play. So instead of guessing and trying to figure out, well, this one seems like it's the code that's most likely to be related to what's happening, and first customer reported about 2 o'clock, so maybe it went out a little bit before that. Airbrake has this great tool called the deployment dashboard that literally will show you every single revision, who did the deployment, and it will show you which errors were tied to each deployment. So you can pretty quickly figure out, aha, this error started happening only after this code was deployed. And by the way, we'll also tell you which errors were fixed. So that if you go and go ahead and roll back a revision or try to put out a fix or a bug, you can then look and say, did it actually get fixed or is it still happening? And do I need to take different action? I just know from my experience, we've spent a lot of time guessing about what to do and a lot of time arguing about whether those guesses were any good or not. And I would have loved to have just had some real anecdotal evidence that proved, nope, this bug was caused by this release. We're either going to fix it real quick based on all the information Airbrake gives, or we're going to roll it back. And we're not going to guess and roll back a whole day's worth of work just to make sure we catch this bug.
All right, check out Airbrake at airbrake.io/changelog. Our listeners get Airbrake for free for 30 days, plus you get 50% off your first 3 months. Try it free today. Once again, airbrake.io/changelog.
Hey everyone, I'm Tim Smith, senior producer here at Changelog. In case you didn't know, we recently launched a new show called Practical AI. It's a show that talks about making artificial intelligence practical, productive, and accessible to everyone. Today, I'm excited to bring you an episode of Practical AI featuring Matt Ryer and David Hernandez of Machinebox. They talked with Chris Benson and Daniel Whitenack, the hosts of this awesome new show, about building a company around AI and democratizing AI. Enjoy.
Welcome to Matt and David from Machinebox. It's great to have you here on Practical AI. I know that Chris and I, when we started thinking about guests for Practical AI, and I was thinking about our slogan or our mantra at Practical AI, which is making artificial intelligence practical, productive, and accessible to everyone. I know the first people that came to my mind were Matt and David from Machinebox. So welcome, guys.
Thank you very much. It's great to be here.
Yeah, thank you.
Yeah. Let's start out maybe with just a kind of brief personal intro from both of you guys. So David, why don't you start by giving us a little personal intro?
Yeah, I'm David Hernandez. So my background is in computer science and engineering. So I was studying back more than 10 years ago in the uni, machine learning and artificial intelligence. And mostly I never used it till recently, the last 3 years that the machine learning was booming, and I started to get through, refresh my knowledge, and I started to implement things. And probably that's how we started Machinebox in some way. And professionally, I've been developing since I finished my degree. It's almost also 10 years doing distributed systems, website. Yeah, my highlights probably I work at the BBC at 2012 for the Olympics. So we were delivering the real-time system to all the stats and all the video player data for the Olympics, basically. Was real nice project. So yeah, that's it.
Sounds great. And Matt, why don't you give us a little bit of an idea of where you're coming from?
Yeah, sure. So hi, my name's Matt Ryer. I've been doing computer science all my career in various forms. I spend a lot of time in the Go community at the moment. I kind of fell in love with Go as a language before it was released as version 1. There was a little experimental tag in Google App Engine, and I wanted to build something on App Engine, and anything that's got a little experimental tag is going to grab my attention. It always has. So I jumped into the language kind of quite early, and I've just been kind of using Go since then, really, wherever I can, and turns out you can use it everywhere. I speak at conferences about Go mainly, and also I have a book, Go Programming Blueprints, which is nice because you build real projects in that book. So it's not a book where you learn the language or you just learn theory. You actually build real things. So it's very practical and very pragmatic. And that's why I quite like the way you guys are approaching this podcast, because, complicated things can be extremely powerful, but they're very difficult for people to kind of marshal and get into a shape that they can put into production. And that's really our philosophy at Machinebox, is to give people a head start on that and get them into production much quicker.
And hey, Matt, while we're at it, what's the name of your book before we go on?
Oh, thank you. It's called Go Programming Blueprints, second edition.
Okay, thank you very much.
You don't have to say it in that accent, but it helps.
It sounds much better.
I think it does help.
So how did you guys originally meet, and how did you start thinking about forming a company together that's focusing on AI?
Well, that's an interesting story. So back a few years ago, I was one of the organizers of Golang UK, the first one, now GopherCon UK, or just GopherCon, I don't know.
GopherCon UK.
GopherCon UK.
Mm-hmm.
So Matt was one of the speakers, so I met actually Matt in that conference. He was in another company before, and I was looking kind of for a job. I was contractor at that time, so I joined the same company that Matt was, and we met there basically. We worked there for a few years.
Yeah, David has a really kind of unique ability to think very clearly about big problems that are otherwise very complicated, and that's a key skill for any team to have. If you can bring somebody in that can look at these kind of big, broad problems, like massive kind of scale, planet scale sort of problems, like you said, like David mentioned earlier, he was part of the team that delivered the software that ran the Olympics, and there's no dry runs of that. You can't say to everyone, guys, can we just, like a week before, can we just have another Olympics just so we can test out all the software? They'd probably say no. So having somebody like that on a team is invaluable, and it was very natural when it came to looking at machine learning and David's expertise in it. It was kind of his eureka moment where he said, we could actually kind of containerize this and deliver it in a way that makes it very trivial for everybody to use machine learning capabilities, rather than having to learn TensorFlow and work in these kind of abstract mathematical models. We could tell some stories differently. We could give people an API that just makes it very clear and sort of changes the way you think about the problem a little bit. It focuses really on the problem that you're trying to solve, rather than technical sort of low-level machine learning components that you might use to solve it.
Yeah, that's great. And again, I think, I've been a Machinebox user for quite a while. I think, very soon after you guys launched, I was super excited about it just because of the practicality of the project. So in terms of like what Machinebox is actually, as a developer, like if I was wanting to use Machinebox to do something, what might that something be, and what would be the interface to doing that?
Yeah, sure. So Machinebox is basically we deliver machine learning models in Docker containers. So what you basically need is Docker installed in your computer that is available in any major platform, Windows, Mac, and Linux. You just Docker pull one of our images. You have a nice API in our images. So you only need to know about HTTP, HTTP APIs to get started and do, for example, face recognition. That is one of our most famous boxes. So you can add face recognition to your stack in just minutes. So that's basic tools. Docker, a little knowledge to do HTTP APIs as a programmer. That probably every programmer should learn that skill nowadays. And that's basically it. You don't need any other knowledge.
So just to clarify, I mean, really, like if I was a data scientist or a developer or whatever I am, there's a lot of APIs out there, both, from the cloud platforms, like with, machine learning, but also other things. Like if I want to send an email or something programmatically, there's like a REST API for that, which uses HTTP and JSON. And so you're saying kind of one of your goals is to really make the interface to doing something complicated, maybe like facial recognition or something, as easy as it is to, send an email via one of those APIs. Is that kind of a good?
Yeah, that's exactly right. Yeah. So essentially, the machine learning that's going on inside the boxes is very complicated, and sometimes we mix different kinds of technologies in different ways and if we tried to explain how to do that, it would be very complex, and I think the deployment would be difficult, and even just managing the dependencies would be a bit of a nightmare. So we take on all that pain and provide APIs that tell different stories. So for example, you mentioned facial recognition. Facebox is a Docker container. You download it, you run it. You then have HTTP access, and the operations you can do are things like, here's an image, tell me all the faces in that image and give me the coordinates of the faces. Not only that, if you recognize these people in who the face belongs to, tell me who that person is as well. And then there's another API call to teach. And we support one-shot teaching, which is also pretty kind of rare still. It just means that with one image, so Daniel, I could take an image of your face and teach Facebox with one example image, and then if we took a big photograph at a conference and you were in it, Facebox would be able to find you and identify you. So you get that facial recognition capability, and it's only a couple of API endpoints you have to learn. It's basically teach this face, and here's an image. Who do you see in there? And then, it's all JSON, because we wanted to just feel really familiar and just fit into what people already had. HTTP and JSON APIs still dominate. They're the simplest to use. You can use them, they're nice because you can just use them in the browser. And when you run one of our boxes, we actually host inside the box a little private website, which you access through localhost 8080. And that website contains all the API documentation, but also lets you interact with the box without even writing any code. Because it's very important on our mission to first of all, communicate what's possible in a very simple way, and then make that easy to play with and get to use so that people can see the power of it. And then once they've sold on that, then it's just a question of making the integration easy and operations. And so we're really focusing on that whole flow end to end. In particular, we care about people without any kind of machine learning experience being able to use these powerful technologies.
So it sounds like Machinebox has been you've taken the machine learning part and abstracted that and put it in a little black box for your end users. Who specifically are you targeting as your customer for this?
Well, we have already paying customers, and so I say already because although Daniel started playing with Machinebox way before we really launched anything. And one of the nice things about the way we approach our developer community is we give them the technology for free early and let them just play with it. And that process, what happens is, first of all, any bugs are immediately found and squashed. Luckily, it doesn't happen very often. We do a lot of testing and test-driven development and other techniques which help us when it comes to kind of code quality. But beyond that, we get to validate the way we've told a story, and also, if the APIs really make sense for the particular way in which their system expects to use a technology like this. So we see customers all kinds. We really only, it's a developer tool. So this is for developers to integrate into their platform. So by and large, all of our audience are developers. But the people that really kind of have so far found it to be useful are people who they understand machine learning in broad terms, some of them, but they know that it's a lot of effort to go to build your own things yourself. And then, if you care about the data not leaving your own network, whether that's on-prem or your own cloud, because we're just Docker containers, you can spin them up anywhere and scale them anywhere. It's, you keep control of all that data. So it's people who they understand, they have already a need, which is great. They've got a problem that they want to use machine learning to solve, and then they use our APIs to solve that problem. So they're basically developers of all levels. Usually, some of them are just JavaScript developers. Some of them are Ruby. We do have a Go SDK, so we have a lot of Gophers. We have a lot of Go people that are using it. So it's really that's who we target. Is basically anyone's a potential target, but specifically we've seen traction in developers who don't want to have to do all the heavy lifting of machine learning and just want to get something and get going.
Yeah, my favorite users are, it's kind of a personal opinion, and it doesn't necessarily mean that is right. So my favorite users are DevOps, or people doing DevOps, basically, because they basically love it, because they usually don't have time or willing to learn any kind of data science. They want to solve specific problems, and they find Machinebox and our APIs really good and really productive for that. So we get a lot of love from DevOps. The best comments that we hear is from people doing DevOps, like, oh, I have this problem, I want to solve it quickly, I want to deploy it quickly, and it's just the perfect tool for that kind of people. And yeah, pretty much.
That's great. I know personally, I can attest to just the quality of the models. I know I actually kind of got into a little bit of trouble at a conference because I was showing Facebox and the kind of one shot updating of the model, and people didn't believe me that it actually worked that well. So
that's happened a few
that
times,
made for
that's happened to us as well.
Yeah.
They think in a demo we've had it where people just think we've spoofed it. I know, it's surprising because we're told again and again, for machine learning to be any good, you need massive amounts of training data. So that's why. And really the solution, I mean, it's kind of a bit secret of what we do, but it's just a clever use of technology inside the box, which allows us to provide that. But the thing is, we don't want people to have to worry about how it works. We just want them to know that it works and integrate it, and get to MVP really quickly. That's really another one of our goals.
A few weeks ago, I was in San Jose at NVIDIA's annual GPU technology conference. And through my employer, I was in a small group meeting with the NVIDIA CEO, Jensen Huang, and he noted something that I see you guys kind of going toward, and that we're really at a junction where software developers are becoming the targets of machine learning rather than just data scientists. And it will continue to be both, but he noted that was a big strategic initiative on them, was to target the software development community, which is somewhat new to these technologies. And it seems that you guys have really centered your strategy around that approach.
Yes. I mean, that's right. I mean, really what happened, if I'm being completely honest, is we just built something that we needed to use. We wanted to use some of these technologies, and it's hard, and we had constraints, and some of them at scale, some of the prices of the machine learning APIs at scale really it's really becomes prohibitive. I mean, it's still quite expensive, and it's quite valuable, I guess. So that's why. But we weren't really kind of too strategic about it in the beginning. We just thought, let's build it how we think it should be built and how we would want to use it. And from there, we've then started to see traction and some great feedback on our developer experience.
This episode is brought to you by Linode, our cloud server of choice. It's so easy to get started. Head to linode.com/changelog. Pick a plan, pick a distro, and pick a location. And in minutes, deploy your Linode cloud server. They have drool-worthy hardware, native SSD cloud storage, 40 gigabit network, Intel E5 processors, simple, easy control panel, 99.9% uptime guaranteed. We are never down. 24/7 customer support, 10 data centers, 3 regions, anywhere in the world, they got you covered. Head to linode.com/changelog to get $20 in hosting credit. That's 4 months free. Once again, linode.com/changelog. And by GoCD. GoCD is an open source continuous delivery server built by ThoughtWorks. Check them out at gocd.org or on GitHub at github.com/GoCD. GoCD provides continuous delivery out of the box with its built-in pipelines, advanced traceability, and value stream visualization. With GoCD, you can easily model, orchestrate, and visualize complex workflows from end to end with no problem. They support Kubernetes and modern infrastructure with elastic on-demand agents and cloud deployments. To learn more about GoCD, visit gocd.org/changelog. It's free to use, and they have professional support and enterprise add-ons available from ThoughtWorks. Once again, gocd.org/changelog.
I kind of want to follow up a little bit on those, that idea kind of that we mentioned around the conference talks is, you kind of use this machine box to do something and it's doing something complicated under the hood and it's giving you great results. But to some degree, even though you might know generally what's happening in the box, it still is a black box. And there's kind of a lot of back and forth in industry right now, at least in the circles that I kind of frequent around, is treating machine learning and AI models as kind of a black box a good thing or a bad thing? And, AI, like I can download pre-trained models and that sort of thing that I don't really understand, right, from the TensorFlow repo and other things. And often really they're, I don't get the kind of results that are either published results or the kind of quality that's promised from these pre-trained models. Now, the models that you're putting out are definitely, I get really good quality, but I still don't really know all of what's going on the inside. So in this case, like we're treating machine learning and AI models kind of like a black box. Why do you think in at least in certain cases, treating models like this, like a black box can be a really good thing? Or maybe what are some downsides or cases in which maybe you wouldn't want to treat them like that?
Yeah, sure. So, all the machine box models are kind of a black box. So in that case, we don't have any explainability for any of the models. But also most of the models are based in neural networks. So nobody has that answer yet in the research. There have some been research about it, but nobody knows what is happening inside.
So you just mean in terms of the complexity of the models?
Yeah. But also for use cases. So, I mean, for example, if you're gonna deny or accept a credit or an insurance, is quite important to understand what a model is predicting. Saying, if my income is less than this quantity, the model is gonna say, you're not gonna get the insurance or you're not gonna get the credit. But for example, facial recognition, you care less about why the model is predicting that this is matching a face rather than not matching this other identity. So you are more worried about the value that you can extract for that matching rather than the value that you can get explaining why the model is doing. So it's quite a balance, and it really depends the use cases. Mostly our use cases doesn't really matter the explainability. In most of the boxes we have, for example, classification box that allows you to build any kind of classifier given text or images. So it may matter most for that kind of model. But in general sense, we more focus on getting value for the models rather to explain what the models do.
Yeah, that's a great point. And I mean, to your guys' point, I think, if you're not able to put your model into production and get any value out of it via a useful interface, then, really what we're talking about is just, AI research that isn't really applicable in a business setting. So you have to be able to get things into production. And I think that's where this sort of black box treatment, in my opinion, is a really good thing in terms of, providing a unified interface for developers and DevOps people and infrastructure people to interact with a model.
But
right?
Yeah, but anyway, it should be, I believe the research is going to come through. Someday we can explain how a neural network do the reasoning and why a prediction is that prediction. So we probably try to keep up with the research, and if that comes through, it's a possibility to add it to the boxes.
Yeah, but those kinds of those sorts of things, and a lot of the arguments against black boxing are it's really, I think, people who are deep in machine learning. They know about it. They want to, they want to invest time and resources into kind of building expertise and things like that. Lots of people aren't in a position where they can do that. So we give them a capability. It's a solution. They are models inside. Sometimes there are multiple ones inside each box, but there's also other things going on in there. So really it is a solution that, the only reason really that Machinebox isn't just completely an open source project is that it's just so complicated that it wouldn't be, I don't think, it's not like it's just kind of a trivial little package that would be sensible to open source and everyone can get use out of. To be able to contribute to the Machinebox code base, I think would be more difficult than other projects. And so that's one of the reservations I have against open sourcing it is that. But yeah, so it's really an audience question, I think. If people care deeply and know a lot about machine learning, then maybe they're going to want to pick up TensorFlow and tackle it themselves. If you're an app developer and you want to quickly, make your software smarter, slotting Machinebox in is just the quickest way to do that.
Yeah, and I think it's like not inconsistent with other trends we're seeing, like TensorFlow estimators and that sort of thing, right? Which is intending to kind of give these modules to people that will let them practically integrate things.
Yeah, right. Exactly. Yeah, it's kind of overlapping. They are catching up with Machinebox for.
And that was a great transition when you were talking about the tooling and under the hood. I assume you're talking about TensorFlow there. What other tooling are you using? Where are you using Go, if any? Love to know how you guys are putting the pieces together.
Yeah, so the basic stack is in Go. So we basically probably more than 80% of the code is Go, because more than 80% of the code is just APIs and network calls and these kind of things. And the machine learning models, the training is done in Python, and our favorite frameworks are Keras and TensorFlow. That's mostly what we use for deep learning. We use other ones like more traditional machine learning, things like Ballpump is a really old C library that I quite like. But basically that's it. It's not not so much machine learning code. We serve all the models in Go, and train all the models in Python or even scripts.
And just out of curiosity, and maybe for the audience, why Go for 80% of the stack? What is it about Go? Because so many people in the AI space are doing Python, they're doing C++. You don't hear Go as often, so I'd love to know why that for your selection.
Yeah, so Go has a deliberately limited language feature set. I once was speaking to a group and I said, you can't do that many things with Go. And it got a laugh because I realized how it sounds. But what I meant was the actual language itself doesn't have that many features, which forces the code to therefore be simpler. You know, in some of the more modern languages with OO, you have big type inheritance. You've got all these language features that allow you to build really quite complicated, very clever and complicated things. The Go philosophy is around simplicity, which mirrors exactly what we're doing at Machinebox. So it fits brilliantly. Essentially, all of our code is Go code all kind of looks the same, so it's all familiar, and you get such kind of benefits at development time, but actually more as you maintain the project. You know, so that's why Go wins, I think, from our point of view. Plus, we're fanboys of Go. There's no denying that. We met at a Go conference. You know, so
much, yeah. But also, some people are really surprised when they ask them. They may hear about Machinebox in a blog post or at a conference. They contact us and say, "Oh yeah, I like your product." Just out of curiosity, how many people are you? Well, it's just Matt and me developing. We have some business side with Aaron, but it's just pretty much three people company right now. And the people get quite surprised, like, oh, you did so much. You have so many boxes, so many products in like 2 people developing and 1 business developing.
Yeah, and the answer isn't that we're awesome, although David is. The answer is that we are very selective about what we do. So we deliberately don't do as much as you could do. There's loads of possible things we could push into Facebox, for example, and some of them tell you where the eyebrows are. I haven't yet seen a good use case for why you need to know in an image where the eyebrows are, but maybe there is one. But until then, we're not gonna invest all that time and effort, and also, you know, add that kind of complexity to the API. So yeah, it's because we're very selective about what we do. We pick the things that we think are just the gold from all this potential kind of complexity, and we just sort of focus around telling that story and solving that problem. So that's how we're able to do so much, it seems, I think.
Go is the perfect tool for our philosophy. It's just it fits really well into that mantra, into that mindset. So it's the perfect tool for us.
I think both of you guys are awesome, just to set the record straight.
Thank you. I was fishing for that. That's why I said it.
Yeah,
I'm glad you picked up on it.
I figured you were. And not only that, but you've given me my next blog post idea, which is around eyebrow-based analysis.
Nice.
Very important stuff.
So,
yeah, you can detect sarcasm with it. That's the only use I think you can detect
Matt,
someone's.
With you,
or maybe anger.
Matt, with you, if you had that sarcasm detector, wouldn't it be pegged most of the time?
Yeah, it would. You can basically just return true.
Okay,
that's a shortcut.
Yeah, that will be 99.9 accuracy.
There was one time where I said something serious and wasn't being sarcastic, but I forget what it was now.
So you've talked a lot about kind of your technology stack, why you've chosen Go. One thing I'm curious about, I mean, so I think everybody should use Machinebox in one way or another, but there's a lot of people out there maybe that are working on data science teams or data engineering teams or whatever it is, and are, you know, maybe using TensorFlow to develop and train models that are getting deployed internally into their own sorts of services and products. I'm curious, kind of, you know, because you consistently produce such high value models that are integrated into your products. Do you have any advice around kind of that progression from training your model to kind of getting it deployed within some type of service, whether that be kind of, you mentioned testing, testing might look differently for machine learning models or AI models than in other cases, but do you have any kind of advice and insights around that process from, training your model to actually integrating it into a service, whether that's integrating Machinebox into your service or maybe that's integrating your own model into your own internal service?
Yeah, so I don't really know. So most of the problems are just technology, that usually technology, you just get it solved one way or another. So there are a lot of tools coming up these days that solve that problem, well, including Machinebox, but also in TensorFlow, the deployment is getting better. So, but I think most important is people. So how this machine learning thing is transforming the way that people see software, especially talking with customers. Now we have, in machine learning, we have a lot of false positives, false negatives. Once you have something in production, they come up with questions. Sometimes the question that most of the customers so we have this problem. That's not actually a problem. It's just a false positive, and there are ways to deal with false positives and false negatives. Changing the mindset to accept that a thing is not a bug, is a false positive in a machine learning model. It changed the way that you interact with people. It's like, you're not gonna have a machine learning that is 100% accurate. So you have to deal with these situations, and that situations is just the way that we are mostly struggling, or just trying to get the right conversations with people. And I think that is gonna come up in any software development in the next couple of years.
Our job, one of our big challenges is communicating what's actually going on. We thought we're just going to deliver face recognition APIs, that's it, or image recognition, image classification, or personalization APIs. And we found that quite quickly we did actually have to get into the conversation a bit more about, look, we don't expect this to get everything right 100% of the time. We expect it to do a much better job automatically than you're doing. Hopefully you can get it to the point where, the exceptions that you have to deal with, if there are any in the workflow, get smaller and smaller. But yeah, that's definitely been something we've had to focus on, is communicating that this is a kind of, unlike other software where you do something and you get a result you don't like, that's a bug. And we've had some bugs opened where it says, I put this image in and it didn't find the face. And of course the face is turned to the side, or it's got a weird shadow on it, or just something is weird about it. And then we kind of get into that conversation. It isn't really a bug. I mean, it's kind of part of the expected workflow. The question is, how do we then tackle that going forward? From a data scientist's point of view, someone did actually ask if they could put their models into our boxes, because they knew the building the models bit, they were good at that, but they had no idea about getting things into production and running them at scale. One of the very early kind of rules that we gave ourselves, and this is kind of common sense now, I think, a little bit, but comes from David's experience building at massive scale for the Olympics in particular, was that we had to be able to horizontally scale the boxes just by adding more of them, because scale is, it's fine if you get this awesome technology and it works nice and slow on one machine, but to really get the value from it, in most cases, you want to run this thing at scale so that it can really, get through work that it needs to get through. And so we spent a lot of time also, which you don't really see apart from the fact that it just works, but we spent a lot of time in making sure that these boxes could horizontally scale in a kind of Kubernetes environment where it was just elastic up and down as you needed. And of course you have to think about what's the state inside the box, how does that work? and various other sort of, will just load balancing across the boxes be enough to get what you want? Or is there more that we need to do, and where does that happen, and all those kinds of things. So yeah, it's been a great sort of experience building it, and it's more fun when people start integrating it and paying for it. That's when you really feel like you've created something valuable.
Yeah, that's great. And I can definitely resonate with some of the things you said around kind of exceptions in models and that sort of thing. I think people too often, in my personal opinion, think about an end-to-end machine learning or AI model that does everything all the time correctly. And I think that's, to some degree, the wrong thought in a lot of cases, because, when machine learning models fail, it's the same, we have an opportunity to refactor them, right? Which is in the end a good thing, right? So just to kind of, getting close to the end here, I was wondering, again, what you guys are doing is kind of setting some standards as far as interacting with machine learning models. And so I'd love to get more advice from you guys in terms of the skills that data engineers or just kind of developers who don't really consider themselves data scientists or AI researchers. What sort of skills would you kind of recommend them, looking into, or what kind of skills do they need to begin to start integrating machine learning into their applications?
I think I don't think you need that many. It depends how deep you want to go into it. The trajectory that I would recommend to somebody who didn't have any kind of idea about it would be to start by consuming APIs and because if that's good enough, if that works for your case, then you don't have to do anything more. And that's what we've found so far. A lot of our customers have said, we're just gonna kind of try this because then we can build the MVP quickly, and then later we might change it. And then that later never happens because the boxes are doing just such a good job that they don't need to then change it. So definitely any kind of API skill around consuming APIs, most people already have those already. And then I think beyond that, it's really just a question of, I think, understanding a little bit more about just the kind of high level concepts, I would say, would be useful. Like, with Classification Box, you can create your own classifier with a training set. Now, with Classification Box, you do need a good amount of examples for each class. So, when some people start using it, they have just a couple of images, a couple of examples, and you can't really get a model that's useful from that. So learning things like the sort of softer skills around machine learning, I guess, which is, the kinds of data, the kinds of problems that machine learning is good at, first of all. Then what kind of training data are you going to have? Because machine learning is only as bad as its training data. So I think those sorts of things would be useful for everyone to have. And then if you're getting into more machine learning technical stuff, then I don't know.
Yeah, so in my opinion, you should focus in one type of problem. So the machine learning is quite broad. So if you want to get started, there are many different subfields. So probably just focus in a problem that you have or you want to solve, like, I don't know, sentiment analysis or classifying text or something more or less straightforward, or in machine learning world, more or less easy. And learning by doing it instead of focusing in maths or things like that. You can get easily lost in that sense. So try to learn by doing. Solve a problem that you have and see how it goes. Once you have that working, you have that boost of energy. Just I have something that is more or less working. Maybe it's not the state of the art. It's not very accurate, but it's better than random. So it's the machine is actually learning, and that is a good feeling. And probably just that is good to get started and get more curiosity and learn about more things.
That sounds great. So let me ask one last question for you as we wind up. So many of the listeners that we have are trying to figure out how to get into machine learning themselves, and they might be software developers, they might be business people who are intrigued by what's possible here. And so as two entrepreneurs who have gone down this road, and you have created a business based on making AI technologies available, and recognizing there's so many people that may want to either supplement their own business that they have or create a new business. What advice do you have for other entrepreneurs that might be interested in taking the same adventure that you guys are now, a couple of years down? What would you say to them?
Yeah, I would always say, solve a specific problem. Make sure you're solving a real problem. This goes for any kind of software, actually. But it's especially machine learning, because it's all cool and sexy and hard. Machine learning's hard. So anyone that, like David said, if you make some ground, you get really kind of big rewards for doing that, like just emotional rewards you get. So yeah, it's kind of difficult to make sure that you're building something that has some true value, because if you're just building cool tech, then there's no guarantee that's ever going to be anything. And often you end up building something that technically is brilliant, but actually doesn't quite fit the problem. And then you have to basically move or change what you're doing so that it does solve a real problem. And that can be quite a painful transition. Usually it involves adding loads of complexity because it didn't quite, you weren't really thinking about those things from the beginning. So of course you want to be able to evolve and learn and move, a project along. But I would say start with a real problem that you understand, and the problem shouldn't be anything to do with machine learning, but machine learning might be part of the solution.
Great. Yeah, that's wonderful advice. And we'll include links, of course, to Machinebox and other things that we've talked about, TensorFlow and Keras and Docker and Kubernetes. If you're not familiar with those technologies, we'll include some good links to getting started with those and learning more. And just want to thank David and Matt one more time for joining us. It's been great to have you here, and really excited about what's going on with Machinebox.
Thank you very much. Yeah, and good luck with the podcast. I think it's awesome. I can't wait for future episodes. I'm sorry to everyone who had to listen to our voices for this episode, but future ones I'm sure will be even more interesting.
Yeah. Thank you very much.
Hey, thank you.
Thank you. Appreciate it very much.
All right, everyone. Thank you so much for listening. You can find more episodes of Practical AI at changelog.com/practicalai. Subscribe to the show and leave it a rating and review in iTunes. A special thanks to our sponsors, Airbrake, Linode, and GoCD. Our bandwidth is provided by Fastly. Learn more about them at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog. The music is by Breakmaster Cylinder. This show was mixed by myself, Tim Smith. Thanks for tuning in. See you next week.